Okay. Yesterday we have discussed about attributes. Attributes are nothing but the variables that are present in the class, or the variables that are present in the entity are called as attributes. Okay? And the variables that are present in the executable blocks are called as local variables. Either in a method or a constructor or initialization block, if we have some variables, those variables are called as local variables. Okay? There are two categories of variables, attributes and local variables. Okay? If it is a local variable, if a variable is a local variable, then doesn't have a default value. If the variable is an attribute, then it has a default value depends upon the data type. Okay? Depending upon the data type, attributes will have default values. Up to long, the numeric variables will have 0, float and double is 0.0, and boolean is false, carries empty character, and for any classes, for any derived types it is null. Okay? And if we come to local variables cannot have default values. It is the responsibility of the developer to initialize the local variables before its usage. The compiler will not take the responsibility of assigning some value to local variables. Okay? It's the responsibility of the developer. Okay? That's what we have discussed yesterday. Okay? And before using a local variable, using means it's not only printing, using the variable, okay, value, okay, using the variable value, okay, using means using the variable value, not printing, not just printing, okay. Before using the variable value, okay, at the time of using the variable value, there should be some value in that variable, okay. Now in this statement, what I am doing is just I'm trying to assign the value of k to j, but there is no value in k, so it is a comparison error. So whenever we are trying to use the value of a variable, there should be some value in that variable, otherwise it will be a comparison error. It might be attribute, it might be a local variable, but this case doesn't arise for attributes just because attributes have default values. But in case of local variables, we should be a little bit careful so that we need to give some value before its usage. Now, will it give a compile time error? Will it give a compile time error? Yes or no? No. Just because before using k, I have some value in k, that is 20. Okay? So, at the time of usage, any variable should have a value, otherwise it will be a compile time error. Now, now, what is the value of I printed? Will it give a compile time error or not? First, check it out whether it will give any compile time error. There are two variables with the same name. There are two variables with the same name. Both the variable name is I. Can I have two variables with the same name?
Yes.
Yes? Is it possible to have two variables with the same name?
Yes, in the different
It's possible to have two variables with the same name in different scopes.
Yes.
Okay? In different scopes, we can have two variables with the same name. But We should not have two variables with the same name in the same scope. Okay? We should not have two variables with the same name in the same scope. But if scope is changed, we can have two variables with the same name. Now, what is the scope of this variable? Okay, it's an attribute and it is available throughout the class. Okay? And this is a local variable and this is available only to this main method. It's not available outside this main method. Okay? This I is available only inside the main method. But this I is available throughout the class. That's the scope of that attribute I. And this local variable I, this is available only inside this method. It's not available outside the main method. It's not available outside the main method. The scope of this local variable is only to that particular block. It's not available outside the block. Okay? The scope of the local variable is only inside the block. Okay? It cannot cross the block in which it is being declared. Okay? But if it is attribute, it can be used throughout the class. It can be used throughout the class. So, within a scope, we can have only one variable with a name. But if the scope is changing, let's consider like in the class scope I can have attribute I, and in the method scope I can have attribute I. So, even though the name is the same, I, the scope is different. So, within the same scope we should not have the same name, but scope is changed, we can have the same name. Now, one question is whether it will consider I which is a local variable or I which is an attribute. Whether it will consider I which is a local variable or I which is a attribute. Definitely, okay. A Java compiler as well as the runtime environment will consider the local variable, will prefer the local variable. Okay? The compiler as well as the runtime environment will prefer the local variable. If the local variable doesn't exist with a specific name, then only it will go for attribute. If the local variable doesn't exist with a specific name, then only it will go for attribute. Now what is the value of I printed? 0. Definitely it will be 0 just because it's giving a preference to the local variable. It will never give a preference to the attribute. It gives a preference to the local variable, and if the local variable doesn't exist with that name, then only it will go for attribute. But we have a local variable with name I, so it will prefer local variable only. So in that case it will print 0. And if I executed it, it's printing 0 just because it's preferring the local variable. Now, will it give an error or not? I is now non-static. I is non-static now. Will it give a compile time error or not? Definitely it will not give a compile time error just because it just considers the local variable. It never considers the attribute if there is a local variable with the same name. So wherever we are using I, it will refer as a local variable only. It will not try. It will never try to search the attribute. Okay. If it tries to point the attribute, then it will be a compile time error. Just because non-static attribute cannot be used directly in static method, but it is not trying to point the attribute. It's trying to point the local variable. So it is not a compile time error. Just because this I, the I that we are using in the ninth line is not referring to the attribute. Okay, it's not referring to the attribute, it is referring to the local variable. If it refers to the attribute, then it is a compile time error. Let's consider that. Now, will it be a compile time error? Yes or no? Yes. Definitely it will be a compile time error just because I is not available as a local variable. So, the compiler will search I as an attribute. Now, do we have I as an attribute? Do we have I as an attribute? Yes. I is there as an attribute, but I is a non-static attribute. Non-static attribute cannot be referred directly in a main method which is static. So it is a compile time error. It's a compile time error just because there is no local variable I available, so it is trying to refer as an attribute. We have a I as an attribute which is of type integer, but that is a non-static, and non-static attribute cannot be used directly in a static method, which is a compile time error. Understood? Now, let me try to compile this. So it is telling like non-static variable I cannot be referenced something. Okay. Let me keep it static. Now, what will be the value of I printed? 0 or 20? What could be the value of I printed? If there is no value in the local variable, will it take from the attribute or will it give any default value like 0 or default value will never be available just because it's a local variable. Now, if there is no value in the local variable, will it take from the attribute? Okay. So if we have a local variable with a name, it will never go for attribute. Whatever it might be positive or negative, it will revolve around that local variable only. It will search. Okay, I am using I in the ninth line. Do I have any local variable declared? Do I have any local variable declared in the main method? Yes, I. It tries to use only I, which is a local variable. Now the second step is it tries to see whether I has any value or not. I doesn't have any value, so it gives a compile time error. Okay, if there is a local variable, then it will never try to find the value of the attribute. Okay, it will never try to refer the attribute. It revolves around the local variable only. Okay, whether it is a compile time error or it compiles successful, whatever the case might be, it will revolve around the local variable. There is a value, it gives a value. There is no value, it gives compile time error. Okay, if there is a local variable with the same name, then it will never go for the attribute. In any case, it might be even a compile time error. So it gives a compile time error just because system.out.println of I is referring to the local variable I, but the local variable doesn't have any value yet. the local variable I doesn't have any value, so it will give a compile time error. So let me try to compile this application. Yes, it is telling like I might not have been initialized. No. Will it print 20 or will it be a compile time error or not? If it is not a compile time error, then what will be the value printed? Okay. What is it doing? It is giving a compile time error. Why it is giving a compile time error? Means wherever it might be, wherever we are referring I, it might be on the left hand side or right hand side or top or bottom, wherever it might be. If there is a local variable, it will try to find local variable only. Okay? If there is a local variable, it will try to find local variable only. Okay? Just some people might think that okay, this is the right hand side, it is I, it will initialize the value with the global variable. Okay, sorry, attribute. But wherever it might be on the right or left or top or bottom, wherever it might be. First, it will try to find I as a local variable. Do we have I as a local variable? If there is I as a local variable, then it will never go for an attribute. Wherever it might be, whether you are using the value or on the left hand side or the right hand side or wherever it might be, it will try to fetch the local variable only. It will never try to fetch the attribute, it will try to refer the local variable only. If it is available. If available, it will try to fetch only the local variable, not the attribute. Understood? Everybody? Is there any confusion with this example? No. This is how, and one more thing is, now what is the value of I printed? What is the value of I printed here? Okay. Two variables should not have the same name in the same scope, irrespective of the data types. Irrespective of the data types, two variables should not have the same name in the same scope. Okay. Two variables should not have the same name in the same scope, irrespective of the data types. Okay, better to compile this. What it says is I is already defined in member demo. So it is telling like I is already defined and you are trying to define a duplicate variable. Okay, it's telling like I is already defined and we are trying to define a duplicate variable. Okay, this is what the error is. Okay, and this is how the attributes will behave. Okay, the attributes can be static or non-static. Okay, the attributes can be static or non-static. How we can make use of the attributes which are non-static, that we will discuss in the next examples. Okay, but it's not mandatory that the attribute should be static. But if you want to make use of that attribute directly in the main method, they should be static. Understood? It's not mandatory that the attribute should be static, but if you want to make use of that attribute directly in the main method, if you want to make use of attribute directly in the main method, what does this mean means? It should be static. Just because since main method is static, if you want to make use of attribute directly in the main method, even that attribute also should be static. For that reason we are making it static. But static has different meaning and a specific purpose. Okay, we should not make all the attributes as static. Once we discuss the objects and object-oriented programming concepts, then you can have a clear-cut idea why static is used and when static should be used. Okay, right now make it not like, since we need to make use of the attributes inside the main method, we are making them static. Okay, it's not, most of the people may think that it's mandatory to make an attribute as static. It's not like that. Since we are using those attributes inside the main method directly, we are making them static. That's it. Okay, and this is how the attributes will be. Okay, attributes and local variables, and the attributes will be available. Okay, the attributes will be available throughout the class. Attributes will be available throughout the class, but the local variables will be available only inside that executable block. They cannot cross the boundaries of the executable block. Okay, but attributes can cross the boundaries. This is how some basics of the attributes. And
if we use the hello of I in main method,
if you use the
hello of I first, then if we declare, then will it be error? Means hello of I is assigned to another variable, then we will declare.
could you please ask a little bit?
Within the main method, if we first use the hello of I, that is declared as attribute, then we again define it as local variable. Will it be error or?
See, if you use any attribute as a local variable, okay, at the time of usage there should be some value. Okay, if you are using first and assigning the value next,
No, I am declaring next as local variable.
you are declaring
Integer I, when I am within the main method, if I assigning the value of I to another variable, then again declaring it as local variable.
first you are using, then declaring. Obviously, then it will not be available, right? See, without initializing also we cannot make use of that. Without declaring, how we can use
So
it?
that will be already declared as attribute.
See, are you declaring an attribute or a local variable?
First it is declared as attribute, then we are using, then again declaring as local variable.
See, the attribute is a different one and local variable is a different one. Okay? First, let's consider like, if you are asking like this, what happens? Okay? See, at the time of usage of I, is there any local variable I? At the time of usage of I, is there any local variable I? No. So what it will do? It will go to the attribute itself. Okay? From the point, you see, you cannot correlate this with this. This is completely different and this is completely different. Just the names are the same. Since names are the same, you might be confused that I am declaring I again. But it's not I declaring I again. This is different, completely different entity, and this is completely different variable. Those two doesn't have any relation. Okay. If I am using I at the 8th line means first it will search before this declaration, do we have any local variable? Before this usage, do we have any local variable? No. Then the next step is it will try to find the attribute. Do we have attribute? Yes. So it will make use of the attribute. But after this statement, let's consider like after this statement, if I am using I, what it will do? Will it try to find the attribute? No, it will try to find the local variable, just because before this point we have a local variable. Understood? Now this is about something about attributes, and we'll switch over to the next member, method. Methods. A method. Why a method is used and how we should use a method. Okay. Now, a method. A method is a block, is an executable block which has reusable code. Which has a reusable code. Which has reusable code. Let's consider like I have 10 lines. Okay, I have 10 lines in my program. The 10 lines are used 10 times. Let's consider like 10 will be confusing. Okay, I have 10 lines of code. I'm using that 10 lines of code at 5 places, 5 different places. Then rather than rewriting the 10 lines of code at 5 places, which becomes 50 lines, what we do is we write the reusable code inside a method and we just call the method. The only purpose and the basic purpose of methods is reusability of the code base. Okay? If we write a method only in a scenario where we are reusing the method at least twice. See, if we are not reusing the code, we won't write a method. If we are reusing the code at least twice, then only we write that code in separate method. Okay? Don't write the methods for each and every requirement. If that code piece is used at least twice, then only write methods. Okay? So, in turn, we can tell that the code that is present in the methods is reusable. Okay? The reusable code should be written in the methods. The only and the basic purpose of methods is reusability of the code base. Okay? Let's consider like in some 10 places we are trying to let's the system.out.println itself. See, if we are trying to write something to the console, let's consider like to write something to the console, we have some 10 lines of code. Rather than writing the 10 lines of code in our application many times in application. Right now, how many times I am using system.out.println? 2 times, right? So, 2 times I am using system.out.println. Now, let me use some 10 times. Now, 10 times I am using system.out.println. So, let's consider like the system.out.println. Println is a method. Now, the println has some 10 lines of code. Okay? Rather than writing the 10 lines of code everywhere in the application, what I do is I write that code in the I write that code in the println method, and again I call the println method itself. Rather than writing the code 10 times, okay, if I write that code 10 times, what happens? This program will become very big and very difficult to understand as well as maintain. So what we do is we build the reusable code inside methods, and we just call the methods whenever that code is required. Okay, that's the main purpose of the methods. That's what system.out.println is doing. Println is a method, and whenever we want to print something to the console, directly we call println. That's it. So it's a reusable code basically. Okay. In the same way, even in our application also, even specific to our application, we may have reusable codes. Okay. That reusable code will be written in methods. The same thing will be done in functions in C language. Functions are for reusability of code. Okay, we can correlate the functions of C to methods in Java, but the syntax will be changing as well as some properties of the method also will be changing. When compared to function, the properties of the methods will be little bit different, and the syntax also will be little bit different. Okay, that we'll discuss. Okay, but we can correlate methods with functions. Okay, now if I want to write a method, let's consider like I have a method test. Now, what is the return type of this? Let's consider like it is a C function. Let's consider like this test is a C function. Let's consider like this test is a C function. Now, what is the return type of this test? The default return type of a function in C is integer or void. Integer. As per my knowledge, it is integer. Very long back, 7 years back, I was studying C. So, I don't remember exactly, but as per my best knowledge, it is integer. The default return type of any function in C is integer. Okay? But here in Java, we don't have any concept of default return types. If we are writing a method, then it's our responsibility to write a return type for a method. There is no default return type for a method in Java. We should write a return type. It's our responsibility to write a return type. There is no default return type in Java for a method. For a method, there is no default return type. It's our responsibility to write a return type. But in C we have a default return type. In Java we don't have any default return type. We should provide a return type. Now, how the method syntax will be means, just first we give the return type. Okay, we give the return type and method name. The method name followed by parenthesis with a open brace and close brace. Okay, it will come from the method name. First, the method name will be there. The method name followed by parenthesis. Before the method name, there should be a return type. Okay, and just open brace and close brace. This is a very simple method in Java. Okay, just a method name followed by parenthesis. Method name followed by parenthesis. Okay, and before the method name there should be a return type. Okay, before the method name there should be a return type. Then after the method, then there should be a open brace and close brace. This is a method syntax in Java. But in C, the functions can have default return types. But in Java, methods will not have default return types. We should enforce a return type. We should give a return type for a method. Okay. The return type tells this is a method name and this is a parenthesis. This syntax is same for C or Java. Okay. And then before the method name, there should be a return type. Okay. And this portion is called as method declaration. Okay. This portion is called as method declaration. This portion is called as method declaration. between this open brace and close brace, we can write any logic or any code. Okay, and this between this open brace and close brace, okay, we can write any number of statements. There is no limit for the statements that we write in a method. Okay, and this is called as method definition or method body. We can call it as this, from this open brace to close brace of a method, we can call it as method definition or even method body. From the open brace to close brace, we call it as a method definition or even method body also. Now, method will have two parts. First is declaration, second is the definition or even body. Declaration and definition. Now, let's first concentrate upon the declaration. The method declaration will have a method name followed by parenthesis, and before the method name there should be a return type. The return type tells what is the value that we are returning from that method. The return type tells what is the value that we are returning from the method. Okay, what is the type of value that we are returning from the method. The return type tells what is the type of value that we are returning from the method. The type of value that we are returning from the method. Now, there will be some methods which just execute some code. There will be some methods which just execute the code but not return any value. There are some methods, there will be some methods which just execute a code but doesn't return any value. Okay? If that is the case, if the method doesn't return any value, in that case also we should have a return type that should be void. If a method return type is void means, okay, we are writing that method and that method doesn't return any value. In case if the method doesn't return any value, then the method return type should be void. In case if we are not returning any value from that method, then the method return type should be void.
Then what will be the difference between calling of method and method declaration? It will not write any return type.
See, method declaration is different. Just we are declaring a method, okay, with a particular definition. Okay, calling the method means using that method. See, you are asking like, what is the difference between constructing a building and living in the building? Constructing a building is different, and using that building, living in that building is different. Method declaration and definition is something like constructing a building. And after constructing the building, what you will do? You will live in the building, you will use the building. So, calling means using that. Declaration and definition, just it will construct the method. After constructing the method, we can use the method for a number of times. Okay? Now, this is a simple test method. In the method, we can write n number of statements, but as a simple example, I am writing system.out.println. Inside test method. Okay, inside test method. Now, this is the method declaration and this is the method definition. In the method definition or method body, we can write any number of statements, and all the statements will be executed if we call the method. Now, this is how we can define a method. Once we define a method, how we can make use of that method? How we can use that method means we should call the method. Okay? How we can call a method means just the method name followed by parenthesis. This is calling the method. This is calling the method. How we can call a method means just give the method name followed by parenthesis. This is how we can call a method. Okay? Then if we call this method, what happens means the control will come here and all these statements will be executed. Okay? All these statements will be executed. Let's consider like this test contains some 10 lines of code. This test contains some 10 lines of code. Then rather than writing the 10 lines of code everywhere, let's consider like I'm calling it 10 places. Rather than writing the 10 lines of code some 5 or 6 times, which makes the code to be 60 lines, I'm writing just 10 lines of code in the test method and I'm calling the test method some 5 times, which reduces the code complexity. Okay? And induces the reusability. Just let me call test method once. This is how we can declare a method and we can call a method. Now, is the test method static or non-static? Is the test method static or non-static? Non-static. Now, in that case, will it give a compile time error?
Yes.
In that case, will it give a compile time error?
Yes.
Definitely yes. Just because a non-static member cannot be used directly in a static member, which will give you a compile time error. Okay, now it will definitely give a compile time error just because a non-static member cannot be used directly in a static member. It can be an attribute or a method, whatever it might be. Okay, a non-static member cannot be used directly in a static member. If you try to use that, then it will be a compile time error. Now, this application will give you a compile time error just because non-static method test is being directly used in a static method main. Okay, so for that reason it will give a compile time error. So first let's see the compile time error. It's telling like high is already defined. It's a previous error. Let me remove this. Okay, non-static method test cannot be referred from static context main. Okay, so now test is a non-static and it is being directly used from a static method main, so it gives a compile time error. So temporarily to execute the test method from the main method, temporarily to execute the test method from the main method, I make it static. Temporarily to execute, just to execute the test from main, I am making it static to avoid the compile time error. But static is not mandatory for a method. Static is not mandatory for a method. But just for the purpose that we want to execute that from the main method. If you want to execute that from the main method, if it is non-static, then it is not possible. Only for that reason we are making it static. Okay, now it will be compiled as well as executed successful. So it's giving inside the test method. Just because we have executed the test method, okay, and the content inside the test method is printed. Okay, and the execution of statements will be as a sequence. Let's consider like we have before calling test, after calling test. Now it will be like a sequence. First it will execute before calling test, it will print before calling test to the console, then it will execute the test method, okay, and again it will come back and then it will execute after calling test. Okay, the execution of statements will be like a sequence. So then, what is the output? Before calling test, inside test, and then after calling test. So the execution of statements will be a sequence. Okay, this eighth statement will not be triggered until it returns back from the method. Okay, the eighth statement will not be triggered until it comes back from the method. Okay, it will be sequential. Now, this static is called as a access modifier. Static is called as access modifier. Access modifier. Okay, we have different access modifiers. Okay, let me list out the things. Okay, these are some of the access modifiers available, and we will discuss about all the access modifiers when the exact time comes. Even we have not yet discussed static, just make it a note like these are called access modifiers, and all these are keywords. All these are keywords. We will discuss about them when the time comes, but just make it a note like all these are keywords and all these are called access modifiers. Now, let me come back. Now, what is the access modifier for test method? Static. Okay, and what is the return type for test method? Void. If we keep the void as a return type, then we are telling that we are not returning any value from that method. Okay, let's consider that we have a method named calculate average. Okay, now and let's consider like calculate average returns some average. Okay, we are writing calculate average method expecting some average value to be returned. Okay, then what we do? Can we keep the void as return type for that method? If we are expecting that the calculate average should return some average value. Now, can we keep void as a return type? No, in that case, void should not be the return type. Void should be the return type only when if we are not expecting a value to be returned. If we are expecting a value to be returned, then the return type should be a specific data type of the value that we are returning. Let's consider like I am returning a double value. So then we should return the average of I and j. Just let me not go for very deep things. Let me remove all these things and let me return just a hard coded average. Let's consider the average is 3.14. Just I have hard coded. Okay, I am not calculating that, just I am hard coding that. Now, this calculate average, okay, this calculate average is a method whose return type is double and we are returning a value 3.14. Okay, now is 3.14 a double value? Is 3.14 a double value? Yes. In that case, now if I want to call any method, whether it has a return type or not, if I want to call any method, just I'll give the syntax of the method. Now, am I using the value that is written from calculate average? Am I using the value that is returned from the calculate average? Yes or no? No. See, directly I'm calling the calculate average method, but I'm not using the value that is returned from the calculate average. See, what happens is just from here. I'm calling calculate average as what it is doing is it's calling calculate average, and from here it is returning 3.14. Now, if I return 3.14 means the value 3.14 will go to this calling statement, and this statement is called as calling statement, or even we call as calling phrase. This is called as calling statement or calling phrase, and this is called as calling phrase. From where we are calling a method is called as calling phrase. Which method is being called is called as calling phrase. Okay? The method that is being called is called as calling phrase. Okay? The statement from which we are executing the method. The statement from where we are executing the method is called as calling phrase. Okay? Now, if we return a value, then the value will be sent to the calling phrase. If we return a value, the value will be sent to the calling place. From the call place, the value will be sent to the calling place. Don't be confused. Call place is the place which is being called. Calling place is the place from where we are calling the method. Calling place is the place from where we are calling the method. Okay? Call place is the place from where the exact method is. Okay? Calling place is the place from where we are calling the method. Call place is the place where exactly the method is. Okay? From the call place, what we are doing? We are returning some value. From the call place, we are returning some value. From the method, we are returning some value. Means from the call place, we are returning some value. From the call place, if we are returning some value, means the value will go to the calling place. Now, other calling place, am I using the value? Am I using 3.14 as a calling place? No. Now, will it give a compile error? I'm sending that value, but I'm not capturing that value. See, I'm sending that value 3.14. I'm sending that value 3.14 from here to some 7th line. Am I capturing that value? No. In that case, will it give any compile error? No. In that case, will it give any compile error or not? No. What's your assumption? No. See, we'll go for market and we'll buy a shirt. Whether using that shirt or not is our responsibility. In the same way, we are calling a method and it is giving some value. Whether using that value is or not is it's our decision. We may or we may not use that value. But ideally, we should use that value if we are calling a method and that method is returning some value means ideally we should use that value. Otherwise, there is no use of calling that method. Understood? See, if you have executing calculate average, and the calculate average is returning some value. The ideal thing is to make use of that value. See, if we are not using that value, we should not call that method itself. If we are not using that value, we should not call that method at all. But if we are calling a method and it is returning some value, for that value itself we have called that method. But if we are not using that value, means it is useless. Understood? So ideally we will use, but even though we don't use the value, even though we don't capture the value, or even though we don't use the value, okay, it will not give any comparison. Okay, even though we are not using the value at that calling place, even though we are not using the value at the calling place, it will not give a comparison. Okay, it will compile successful as well as it will execute successfully. See, using the value is up to the developer. The developer may or may not use, but the compiler will not give you any compile error, irrespective whether we are using the value or not. See, before calling test, inside test method, and after calling test, is executed, and then let me try to capture the value that is sent. Okay, let me try to capture the value that is sent, and let me print even d. Now I am capturing the value. Okay. Now, if we print the value of d, it will what it will print? It will print 3.14. Just because we are executing calculate average, which is sending 3.14, and we are assigning to d. Now, what is the value that is printed? 3.1. So, if a method return type is if a method return type is other than void, okay, we should return some value. Let's consider that the method return type is void, and if we are returning some value, then it is a compile time error. Void methods should not return any value. Void methods should not return any value. If you return any value from void methods, then it is a compile time error. Void methods should not return any value. Void methods should not return any value. If we try to send some return value from a void method, then it is a compile time error. If the return type is void, then we should not return any value. Void methods are supposed, okay, just for execute, not to return a value. If we want to just execute a method, but we don't want to return any value, then only we use void. But if we are using void and we are returning some value, then it is a compile time error. Void methods are not supposed for that. Void methods are supposed to be used only when, if you want to execute a method but don't return any value. Void methods are supposed to be used only when, if you want to execute the method but need not to return any value. In that case only we use void methods.
So if you are not interested in using the value of method, returning value of method, then why we are calling the method?
That's what, for demoing I am calling a method. But in real scenarios, if you call a method and if you are not using the value of a method, it's useless. That's what I told, right? Just to give a demo to you, I am just calling the method. But in real scenarios, if we are calling a method for some value and it is returning some value, and if we are not using that value, then it is useless. In general, we won't do that in real scenarios. But it is a demo class. Okay, it's not exact real scenario. Now, so this will give you a compile time error just because we are trying to execute calculate average and the return type is, let me not make use of this. Now we are calling the calculate average which is returning 3.14, but the return type is void. So the return type should not be void if you are returning some value. See, D is not there, right? Let me remove this. Now, what is telling? Cannot return a value from the method whose result type is void. So, if the return type is void, then we should not return any value. Now, let me keep the return type int. Now, the return type can be the same or higher than the returned value. The return type can be the same or even higher than the returned value. The return type can be the same or even higher than the returned value, but it should not be lower. It should not be lower. The return type can be the same or even higher than the returned value, but it should not be lower. The return type can be the same or higher than the returned value, but it should not be lower. The return type can be any data type. The return type can be any data type, and the return type can be the same or even higher than the returned value, but it should not be lower. Now, what is the data type of the return value? What is the data type of the returned value? What is the data type of the returned value? What is the data type of the? I'm not asking what is the data type of the return type. What is the data type of the returned value? Double. It is double. The default fraction numeric is double. Okay? By default, fraction numeric will be considered a double. So, the return value is double, and but what is the return type? Int. Is it higher or lower than the return value? If it is the case, it will give compile time error. Okay? The return type can be the same or even higher than the returned value, but the return type should not be lesser than the returned value. So, if it is the case, it will give a compile time error. Just we are trying to the return value is found is double, okay, but it is required as int. Okay, so the return value should be compatible with the return type, and in turn, in the either way, in the reverse case, we can tell that the returned value can be the same or lower than the return type. In either way, we can tell the returned value can be the same or lower than the return type. Understood? The return type can be the same or higher than the return value. That's the same like the return value can be the same or lower than the return type. Okay? The return value can be the same or lower than the return type. Now, will it give a compile time error? Yes or no? Yes? What's doing? It's telling like 3.14 is double, as we told in the yesterday's class. Okay? By default, Java will consider a fraction numeric as double. Okay? By default, Java will consider fraction numeric as double. Okay? So, the return type is float, which is lesser than double. So, what we can do is we can typecast into float. Or even we can keep f, but while calculating dynamically, we cannot keep f. See, if we are hard coding 3.14 means we can keep f. Let's consider like we are making it dynamically. Let's consider now. Can we make it float? Can we send directly like this? Can we send directly? No, right? Directly? Just this 3.14 will be considered double. So we should typecast into this ideal way. Rather than keeping F, this is the ideal way of doing. Just typecast into float. Then it will be valid. All of you know typecasting, right? All of you know? Just it will typecast 3.14 into a float value. Is this necessary? Yeah, that's what we have done previously. Previously, that's what we have done. We have typecast into float. After that only we have declared double variable and then we have typecast. Okay. Either we can do or D. Either way can be fine. Okay. But anyhow, the return value is important. The return value can be the same or can be lower than the return type. Okay, that's what the stuff. And if the return type is other than void, definitely there should be a return value. If the return type is other than void, if the return type is other than void, okay, then there should be a return value. If the return type is other than void, then there should be a return value. Now, what's the return type? What's the return type? Float. Is the return type void? Is the return type void? No. Then is there any return value? No. If the return type is other than void, then there should be a compatible return value. But we are not returning any value here. Okay? It's telling like missing return statement. We should return some value. Okay? And now, will it compile successful? We are returning some value. We are returning some value. Will it compile successful?
No.
There should be return value, and the return value should be compatible with the return type. There should be some return value. At the same time, the return value should be compatible with the return type. What is the return type? Float. Can float accommodate nulls? Nulls can be accommodated only by the derived data types. But float is a primitive. Float is primitive. For primitives only some specific values, numerics or some specific values can be assigned. Nulls can be assigned only to derived data types. Null can be assigned only to a derived data type. But is float a derived data type? Float is a primitive data type. So we cannot return null for a primitive data type. So there should be a return statement as well as the return value in the return statement should be compatible with the return type. There should be a return statement as well as the return value in the return statement should be compatible with the return type. The return value in the return statement should be compatible with the return type. Otherwise, it will be a compile time error. Now, is it compatible with the return type? Is null compatible with the return type? Null is a derived value, but float is a primitive data type. So these are incompatible values. So now, if we try to compile this, it's showing like it's incompatible type. Okay, just we are returning null, but actually required is float. Now, will it compile? Yes or no? No. Just because the return type is float, even false is a primitive, it's boolean, but it is float. Those are incompatible. False is of type boolean, float is of different data type, so it's incompatible. So the return value should be there as well as the return value should be compatible with the return type. It's telling like it found boolean, but actually it's required float. Okay. Now, will it give any error? What it is doing? It's found in, but it should be short. Just because by default a fractional numeric will be considered a double and non-fractional numeric will be considered a integer. So it's considering this value as integer, but the return type is short, which is lesser than the integer. Okay, so that it is a compile type error. Now, if I make the return type as integer and whether to compile, execute the application, it will be successfully executed. Okay, so the return type and the return type value, the return type and the return value should be compatible. Fine. Now, what is the order of execution? What is the order of execution? Before calling test? Inside test? Now, how many of you say that? Please raise your hands. How many of you say that end of the test method is executed? Not even a single person? Now, how many of you tell that before calling test, inside test, and after test? That means half of the persons doesn't have any opinion. Okay? This is a compile time error just because the return statement should be the last executable statement of a method. The return statement should be the last executable statement of any method. The return statement should be the last executable statement of any method. That's why if one, we have so many return statements also. Okay? Only one return statement should be executed, right? Yes, that's what I was saying. The process of execution itself. Okay. Let's consider it practically. See, consider that. Let's consider that it comes here, and if it is returned from 14th line itself. Is there at least one scenario where the 15th line is executed? No. The process itself, let's consider I have a return type after the 15th line. Let's consider like I have a return type in the 17th line. Like this. Now you are telling that I have multiple return types. But see, from here itself it will return. Is there at least one single scenario where this 15th or 16th is executed? No. The process will come here and return directly from the 15th line. There is not even a single scenario where these two lines are executed. So they have framed a rule like, okay, the return statement should be the last executable statement of a method. The return statement should be the last executable statement of a method. Okay? The return statement should be the last executable statement of a method. So this gives you a compile error just because after return statement there is another statement. Okay? The return statement should be the last executable statement of a method. Now, let me not keep system node order println. Now, will it give you a compile time error? Will it give a compile time error? Yes or no?
Yes.
Event variable declaration is also a statement. Event variable declaration is also a statement. Okay? So that we are ending with semicolon. Okay? Any statement will end with semicolon. Event variable declaration is also a statement. So, not even a single statement is valid after the return statement. Okay? The rule is the return statement should be the last executable statement in a method. The return statement should be the last executable statement in a method. Now, will it give a compile time error? Calculate average is non-static. I have made the calculate average as non-static. Will it give a compile time error or not?
No.
Calculate average is non-static. Will it give a compile time error or not? Yes or no?
No.
See, keeping non-static method is not a sin. We can keep non-static method. But the sin is, we should not call that non-static methods directly from static methods. Then it will be a compile time error. Keeping non-static methods is not a compile time error. Calling non-static methods from static methods is a compile time error. Now, are we really calling calculate average? No. Since we are not calling calculate average, it will not be a compile time error. If we call calculate average from main, then it will be a compile time error. Just because main is a static and calculate average is a non-static. We can have any number of non-static methods. It's not a problem. But we should not call non-static methods from static methods. Then it will be a compile time error. Understood? Once we call this method from main, definitely it will be a compile time error. Just because main is static but calculate average is non-static. Understood? Now, is this valid? Will it give a compile time error?
Yes.
Yes or no? I am not calling the method. If I am not calling the method, will it compile? If I am not calling the method, will it be compiled? Definitely yes. Okay, it will be compiled irrespective whether the method is called or not. Irrespective whether the method is called or not, the method will be compiled. If you are compiling a .java file means each and every statement in the .java file will be compiled. Irrespective whether the method is called or not, it is a statement inside the .java file. All the statements in the .java files will be compiled irrespective whether they are used or not. Irrespective whether they are used or not, all the statements in the .java files will be compiled. Okay? So, even calculate average will be compiled just because it is a statement in the .java file and we are compiling the whole .java file as a unit. It's irrespective to the compiler whether that is used or not. Whether that is used or not is irrespective to the compiler. The compiler will take the .java file and compile each and every statement in the .java file. So, it will compile even calculate average method also. If it compiles the calculate average method, then will it give a compile time error or will it compile successfully? If it compiles this method, then is there any compile time error in the method? Is there any compile time error? Yes. The return type is, what is the return type? Integer. What's the, the return type is string. The return value is integer. Okay. So it will give a compile time error that the return value is integer but the return type is string. Okay. It's found int but it should be string. Then how we can represent it as a string means whatever the content in double quotes, it is represented as string. Now it is a string. Whatever the content in double quotes, it might be numeric content, it might be special character content, it might be alphabet content, whatever the content in double quotes, it's considered to be a string. Okay? Whatever the content it might be, if it is in double quotes, it's considered a string. Most of the people think like 1, 2, 3, 4, 5, 6, it is an integer, but since it is in double quotes, it will be considered a string. Now it will be compiled and even executed successful. Okay. Now I am returning HCU. Okay, I am returning HCU which is a string and even the return type is a string. Now, what's the order of execution? Compile time error? Really? Definitely this is a compile time error. Just because calculate average is a non-static method and we are calling it from the static method directly. Calculate average is non-static and since we are calling that calculate average directly from main which is static, it will be a compile time error. Previously it was not a compile time error just because we were not calling that method. It will be compiled successful just because the method return type is string and return value is HQ which is also a string. But if we use that method inside the main which is static, then it will be a compile time error just because the calculate average method is non-static and it is being used directly in main which is static. So now it will be a compile time error. Now let me make it static. Now it will compile successfully. Okay. Okay, it was compiled successfully and even it will execute successfully. Now, can I have member demo as a return type? Can I have member demo as a return type? Yes or no? Yes. Just because any data type can be a return type. It might be primitive or even derived. Okay? Now, what's the order of execution? Okay? Both are derived. See, what is the value that I am sending in double quotes? I am sending HCO, which is a string. The return type is member demo, which is also a derived data type. See, the value that I am sending it is derived, and the return type is also derived. Now, will it give an error? Will it give an error? Yes or no? See, even both are derived. Both are different classes. Okay? A string is a class which is used to accommodate this string, and member demo can accommodate a value of type member demo. But what we are doing, even both are derived. Even both are derived, string is different, member demo is different. So those two are different classes. Okay, we cannot assign a value of string to member demo as well as we cannot assign a value of member demo to string. So those two are completely different. Even those two are derived data types. Member demo is separate class and string is another separate class. We cannot assign the value of a string to member demo. It's not possible. It's incompatible. Even both are derived, those two are incompatible data types. We cannot assign the value of a string to member demo. Or let me keep system. Both string and system are library classes. Now, will it compile successful? No, just because even both string and system are derived data types. Even both string and system are library classes. Those two are different classes. System cannot hold a string. Okay, so the return type and the return value should be compatible. Okay, now it is a compile time error just because the return type is system but the return value is string. It's telling like the return type is the return value required is system but we are sending a string. Now will it compile successful? Yes or no? Yes, just because null can be assigned to any derived data type. Null can be assigned to any derived data type. Null can be assigned to a string or system or any derived data type. Or so it will be compiled as well as executed successfully. Just because null can be assigned, the null value can be assigned to any derived data type. It is irrespective whether it might be a class which is there in the library or a class which is there in the application. Now, if we try to compile it, it will be compiled and even executed successfully. Now, if I change the return type to member demo, now it will compile and execute successful? Definitely, it will compile as well as executed successfully. Okay?
Now, what's the value? What is the value that I am assigning to str? Null. Now, member demo, can it accommodate null? Member demo, can it accommodate null? Yes. Now, is there any error here?
No.
It is a compile time error. Just because the compiler will check for variables, the compiler will check only the data type, not the values. For variables, the compiler will check only the data types, not the values. What is the variable? str. What is the data type of str? String. So it will check only the data type. What is the data type? String. Can I return string to member demo? No, it is not possible. For derived data types, for the variables of derived data types, the compiler will check only the data types, not the values. For the variables of derived data types, the compiler will check only the data type, not the value in that variable. For the variables of derived data types, the compiler will check only the data type, not the value. See, the value is, if the compiler considers the value, it is null, and null can be accommodated by member demo, but it is not the case. The compiler will check only what is the data type of str. We are returning str, and what is the data type of str? What is the data type of str? String. Then the compiler will think that we are trying to return a string. It doesn't bother what is the value in str. It might be null or x or y or z. But the compiler will never check for the values of variables for derived data types. For derived data types, the compiler will never check the value of the variable. It will just check the data type. What is the data type? And is the data type compatible? Is string compatible with member demo? Is string compatible with member demo? No. So it is a compile time error. Understood? It never check what is the value. It never check. The compiler will never check what is the value. Just it will check what is the data type. Okay? That's for derived derived variables. You see here, it is like we are trying to return a string, but actually it is required member demo. Okay? But if you directly send a null, then it is no problem. There is no problem. Just because null is directly a value, it's not a variable, it can be directly sent to a derived data type. Null is not a variable, it's directly a value. So the null value can be directly sent to a derived. This is possible. Understood the difference? What is the value that is written here? Null. Now, can str accommodate nulls? Can str accommodate null value? Yes. Now, is there a compile time error now? Is there a compile time error now? Yes or no? Again and again, just now I have told like the compiler will never check the values for variables. The compiler will check only the data type. Now, what is on the right hand side? What is on the right hand side? Calculate average. See, for this, on the right hand side is calculate average. Is it a variable or a method? Method. For variables means it will check the data type. For methods means it will check the return type. What is the return type of the method? Member demo. So the compiler will think that we are assigning a member demo to string. For variables it will check the data type. For methods it will check the return type. So the compiler will think like the compiler will never consider what is the value that is returned from the method. But the compiler will think like on the right hand side it is calculate average. Then it will check the return type of calculate average. What is the return type? Member demo. Okay? Return type is member demo. So on the right hand side the compiler will think like it is a member demo. What is on the left hand side? String. The compiler will think like I am assigning member demo to string. So the compiler will never check the values. The compiler for methods it will check the return type, for variables it will check the data type. Understood? What is the value in it? It will be checked only by the runtime environment. But the compiler for derived data types, it will never check the values, it will check only the data types. Is the data type compatible or not? If it is attribute, sorry, if it is a variable, it will check the data type. If it is a method, it will check the return type. Understood? Okay? It's how it will behave. If it is attribute or a variable, it will check the data type. If it is a method, then it will check the return type. But what is the internal value? It's up to runtime environment. It's not up to the compiler. For derived data type, the compiler considers only the data type. For methods, only the return type. Understood? Now? Now? What will you do? Definitely it will be a compile time error. Just because calculate average is not returning any value, but we are trying to assign the value to str. Without having any value, how we can assign a value? It's not possible, right? Definitely it will be a compile time error. Okay? So void methods should not be in the right hand side of the assignments. Void methods should not be there in the right hand side of the assignments. Okay? It will be a compile time error. Void methods should not be there in the right hand side of the assignments. This is a compile time error. Okay? Just because the compiler is expecting calculate average to return some value, but it's not returning some value. Just because the compiler is expecting calculate average to return some value, just because we are assigning to string. But this calculate average is not returning any value, but we are trying to assign the returned value to string. It's not returning any value, but we are trying to assign the returned value to a string. It's a conflict. So it will be a compile time error. Okay, it's found void, but it's required string. Now, is it a valid thing? A return statement for a void method? Can I have a return statement for a void method? Just revise your notes. What I told? Did I told that there should not be any return statement for void method? Did I tell like that? What I told? We should not return any value from a void method. But there can be an empty return statement in the void methods. What I told previously is we should not return any value from void methods. I did not tell that there should not be a single return statement in the void methods. Return statements are possible in void methods, but it should be an empty return statement. It should not return any value. Return statement is possible for void methods, but it should not return any value. It should be empty. It should be an empty return statement. What a empty return statement is, let's consider like I'm coming to this method. Let's consider like I'm calling a method calculate average, and from here this is the calling place and I'm coming to the call place. This is the calling place and I'm coming to the call place and I'm executing here. Now, do I have any return statement here? Is it a void method and do I have any return statement? No. If that is the case, then what a compiler will do means the compiler will keep a return statement. It cannot go back as it is. Okay? It cannot go back by its own. There should be some statement which returns back the control from here to here. Okay? For void methods, if we don't keep return statement means at the end compiler will keep the return statement. Empty return statement. This will be kept by the compiler just because we did not keep any return statement. If we don't keep any return statement for void methods, then the compiler will keep an empty return statement just because the control cannot return from this method as it is. It cannot return the control by its own. There should be some statement, there should be some trigger which returns back the control from here to here. That trigger, in case of void methods, will be an empty return statement and it will be kept by the compiler if we don't keep. Okay? If we don't keep an empty return statement, okay, then the compiler will take the responsibility of keeping an empty return statement. Then, through this empty return statement only, the control will be returned back to the calling place. It's not returning to the calling place by its own. It cannot know. It's just a code. It doesn't know how to return back. But by this statement, the compiler keeps this statement at the end for void methods. Let's consider that I am keeping the empty return statement. Now, will the compiler take the responsibility of keeping the empty return statement? Since I have kept the empty return statement at the end, will the compiler take the responsibility of keeping the empty return statement? No. Either we keep or the compiler keep. It's irrespective. Okay? There should be empty return statement at the end for the void methods to return back to the calling place. Okay? If we don't keep any empty return statement, then it's a responsibility. Then the compiler will take the responsibility of putting an empty return statement at the end. Anyhow, the method cannot return by its own to the calling statement. Okay? There should be some statement there should be some trigger which returns the call, which returns the control from the call place to the calling place. That trigger for void methods is the empty return statement. If we don't keep the empty return statement, then the compiler will give the empty return statement. Okay? Either it's our wish. Either we can take the responsibility or we can delegate the responsibility to the compiler. But empty return statements are possible for void methods. Return statements are possible for void methods, but return values are not possible. There is a difference. Understood the difference? Now, can I return like this? Can I return null value for a void method? No, just because any return value is not possible for void methods. Now, how it will behave? Whether it will be an error or it will be executed successful. Error? Why this error? Return statement should be the last executable statement. Whether it is returning any value or it is not returning any value, it's irrespective. The return statement should be the last executable statement for any method. Irrespective whether it is returning any value or not, the return statement should be the last executable statement of any method. I'm telling last executable statement. It's not the last statement, it's the last executable statement. There is difference between last statement and last executable statement. Okay? How that makes the difference, we'll discuss in the next class. Okay? Actually, we have planned the next class in the morning at 9:30, but because of some urgent personal commitment, I could not able to take the class. Okay? Just we'll take the class somehow. Do you want the class on Sunday? How many yes? How many no? So, no class on Sunday. We should have a holiday, right? Your buddies, we can enjoy now. Why to build up? Okay? Most of them are giving some build up. Yeah, we can attend even on Sunday. But it's not possible for us until it is mandatory. If it is mandatory, yeah, we'll keep. Okay? Directly on Monday. Monday it is 6 only. Monday 6 o'clock only. Monday 6 o'clock. Okay?